3, 2, 1.
MDS to
We have ignition. We have a liftoff.
roll program is in on time. Vehicle response is normal.
At nearly 15 billion miles from Earth, Voyager 1 drifts through a region no spacecraft was ever designed to survive. It was launched in 1977. Jimmy Carter was president. The internet didn't exist. Most of the engineers who built it are now retired or gone. And yet Voyager 1 is still out there, still transmitting. A 23-watt signal, weaker than a refrigerator light bulb, traveling for more than 22 hours across interstellar space before reaching Earth. Every command NASA sends takes nearly 2 full days to confirm. There is no live control, no immediate correction, no second attempt, just patience and hope. Recently, NASA's Deep Space Network prepared to send what was described internally as a final major recovery command. Not a shutdown, not an end-of-mission message, but something almost as risky. Because Voyager 1 had begun behaving in a way that deeply unsettled its engineers. It was alive, but it wasn't making sense. The first signs were subtle. Voyager was responding to commands, its transmitter was functioning, carrier signal strength was stable, but the telemetry, the scientific and engineering data embedded inside the signal, was corrupted. Not silent, not random static, structured, but wrong. Temperature readings that violated physical limits, power levels fluctuating beyond hardware capability, attitude data implying the spacecraft was spinning when it clearly wasn't. It was as if Voyager's brain was still speaking, but the meaning inside the words had fractured. And that is far more dangerous than total silence. Voyager 1's onboard computer is ancient by modern standards. Its memory is measured in kilobytes. Its flight data subsystem was designed when slide rules were still common in engineering offices. There is no redundancy beyond what 1970s technology allowed. Cosmic radiation has been striking its circuitry for nearly half a century. At that distance, beyond the heliosphere, in the interstellar medium, the sun's protective magnetic bubble no longer shields it. High-energy particles constantly bombard its systems. Over time, radiation can flip bits in memory. A single flipped bit in the wrong location can corrupt how data is formatted. Engineers suspected exactly that, a failing memory sector. But identifying which one and fixing it remotely was another matter entirely. The proposed solution was surgical. Isolate the suspected corrupted memory region, rewrite the telemetry formatting code, reroute operations around the damaged section. In modern spacecraft, this would be routine. On Voyager 1, it was dangerous. Because no one had attempted a memory restructuring at this scale since the 1980s. And every command sent to Voyager carries risk. If the patch overwrote the wrong region, if the failing memory-controlled command interpretation, if another bit flipped mid-upload, Voyager could stop responding forever. There would be no second chance, no rescue mission, just silence. NASA made the decision. The Deep Space Network transmitted the command sequence. Then the waiting began. 22 hours for the signal to arrive, another 22 for the reply. Inside Mission Control, engineers watched for the carrier tone. If it returned, Voyager was still alive. If it didn't, the carrier appeared, on time, stable. But when the first telemetry packet was decoded, something felt wrong. The corruption had spread. More subsystems were reporting impossible values. Thruster temperatures reading below absolute zero, voltage lines fluctuating in patterns that didn't correspond to real hardware behavior, orientation data contradicting star tracker expectations. The spacecraft wasn't tumbling. Its signal strength proved it remained properly oriented, but its internal logic was misreporting its own condition. That's when the regret set in. Because minutes after NASA contacted Voyager 1 one more time, they realized they may have pushed a 46-year-old machine closer to its edge. Voyager 1 is currently traveling through interstellar space. It crossed the heliopause, the boundary where the sun's influence fades, in 2012. Out there, plasma density changes, magnetic field structure shifts, cosmic radiation increases. This is a region humanity has never directly sampled before Voyager. Every byte of data it sends back is historic, but that environment is unforgiving. Electronics degrade slowly and invisibly. Shielding weakens. Solder joints fatigue from decades of thermal cycling. The spacecraft was never meant to operate this long, and yet it does, barely. Engineers dug into archived documentation. Original schematics were pulled from physical storage. Some code exists only on printed paper, typed decades ago. Retired engineers were consulted. They were trying to reconstruct the internal logic of a machine older than most of the current team. Eventually, they identified the likely failure. One memory bank within the flight data subsystem had partially degraded. Voyager was collecting real science data, but when assembling telemetry packets, corrupted memory produced nonsensical outputs. The fix required rewriting how Voyager organizes its own telemetry. Not replacing hardware, rewriting logic at 15 billion miles. The team broke the patch into smaller segments, small enough to fit into known healthy memory regions. They uploaded it in stages. Each upload took nearly 2 days round trip. If a segment failed, the process would halt. The risk was cumulative. Every successful upload increased the chance of destabilizing something else. Because the remaining hardware is not young, it is aging silicon floating between the stars. Then came the moment of truth. Another command cycle completed. Another 44 hours of waiting. The signal returned. Telemetry packets decoded cleanly. Temperature stabilized, power readings normalized, orientation data aligned with starfield expectations. The patch had worked. Voyager 1 was stable again. For now. But the event changed something fundamental inside mission control, because it proved how thin the margin really is. Voyager runs on 3 radioisotope thermoelectric generators. Each year, they lose a little more power. Instruments have already been shut down to conserve energy. Heaters turned off. Subsystems permanently disabled. Eventually, there will not be enough electricity to run the transmitter. When that day comes, Voyager will not announce it. It will not send a final message. It will simply stop and continue drifting forever. Minutes after NASA contacted Voyager 1 during that critical repair window, the regret wasn't about failure, it was about proximity to the end. Because every command now carries weight, every adjustment risks being the last. Voyager 1 has traveled farther than any human-made object in history. It carries the golden record, a message from Earth etched into gold-plated copper, music, languages, sounds of oceans and wind, a time capsule for a civilization that may never find it. And yet, its survival now depends on engineers carefully managing decaying 1970s hardware across interstellar space. That is not dramatic. That is fragile. And fragility at that distance feels enormous. Voyager 1 is still transmitting. Its signal is faint, but it is there, traveling across billions of miles of darkness to reach us. One day, NASA will send a command, and nothing will come back. No telemetry, no carrier tone, no whisper. That silence will not mean failure. It will mean Voyager finally outlived even its ability to speak, and when that day comes, humanity will have something we have never had before. A machine we built, still traveling between the stars, but forever beyond our reach.